Hello. This again is one of the videos where I'm going through the 2025 challenge from Everybody Codes many months after the challenge was posted. And tonight I'm going to start with Quest 16. However, before I start the timer, let's get my boilerplate in place. I forgot to do this ahead of time, so we'll just go ahead and create Quest 16, and the boilerplate here we're going to do by copying Quest 15 and then stripping it down to just boilerplate. If I need that type, I will recreate it later. Or scanner.scan. Return 0. This is what I have for my boilerplate. Possibly I should work on something better. I know that some people for this have some kind of extensive boilerplates forms where they put problems 1, 2, and 3 in separate files, and they also have libraries of utility functions ready to go. I don't really have that. I have a small library that I use when doing Advent of Code. I suppose I could build up a golang library here for Everybody Codes as well, but that hasn't been necessary yet. Okay, boilerplate is all ready to go. Let us get on with the quest. Before I do that, I've got to start the timer. Okay, on with the quest. Come out of the tunnels. Closer. Length 90. Okay, so this seems fairly straightforward. There we go. Data string. Text. Scanner.scan. heights make int 90. Remember in Go, when you make an int, when you make an array, the array is filled with whatever the 0 value is for that type, or 0 in our case, which is exactly what we want. So for data range datas val ignored error strconv a to I data for just to make sure I place this at the right spot. The first one we place total. We don't actually need column heights. Equals val heights bracket I. Yeah, we don't actually need column heights. So I'm just gonna go run quest 16. Right. I did download the file though, right? Quest 16. Forgot to move them. 202. Yay, okay. And frankly, that took me longer than it should have. Beginning of calculate the product of all numbers from the spell that created the wall. Okay. Right. Okay, datas becomes call height, actually call heights bracket idx plus 1 equals val. Okay. So we get the number, we take it off. We get the number, we take it off as many times as needed. Okay. So first non-zero for call heights bracket first non-zero called spell factor. Actually, let me do this. Let me do spell factor less than len call heights. If call heights bracket spell factor is not 0, break. Okay, so if spell factor heights the length of column heights okay heights bracket spell factor for range molt dot product times equals spell factor for x call heights x equals spell factor call heights x minus equals molt. Okay. Doing part 2. Did I download part 2? I did not. Download. Yay! Okay. Excellent. At least one block. How long the wall is. Goal is to find out how long the wall, how many columns. Knowing the builders had that many. Ah! Okay. So. Okay, so the question is, if I could do all of that, how many 2025 3 times 1,000? Okay, so the question is, if I could get there, how many blocks would be needed? Okay, so basically once I have the spell, then the number of blocks needed to get to a specific point I mean, I can figure out the number of blocks needed to get to a specific point, right? Because I just do. Okay, so to get to 3, so for okay, so to get to get 2 columns, and if I have 2, I just use 1. Yeah, so it's just div. Okay. Okay, so I'm not going to do anything too clever. I'm just going to do this, do a like exponential to get there, and then do a binary search to find the right value. Okay. So I run this to find my spell factor. Instead of total product, I have spell okay, wait. So what do we have here? Beginning of the wall. Okay, the beginning of the wall tells you how much. Spell append spell factor. Okay, now. Okay, so that gives me the spell. Now what I need is I need a function to func blocks needed int calls int spell array of int for x change spell val plus equals calls slash x return val. Okay, for that, okay, and now I have low and high. One high colon equals 10. So while high is too small, we keep doubling it. For blocks needed high spell less that blocks target. For high minus low greater than 1. Mid equals high slash 2 plus low slash 2 plus if high percent low percent 2 plus 1 mid plus plus. Okay, yeah. Then what we do is we say, I mean, this little jumping around probably isn't needed, but it's just paranoia in case high plus low blows the size of int. I'm sure it won't. I'm sure that they kept far away from int64 boundaries, but you know, it's just good practice to apply some paranoia sometimes. Okay. Colon equals blocks needed mid spell if val is less than blocks target low mid, else if val greater than blocks target high equals mid, else return mid, return low. Download. Yay! Okay, that was sufficiently fast that I'm going to go ahead and attempt quest 17. Push my luck. I'm sure that after such a relatively easy quest 16, quest 17 is going to be a bear. But, oh well. Yeah. observe them. Lava flows past, forming a perfect circle. Okay. Okay, download. Now I'm going to do something that I haven't done before, just to get stuff going a little bit faster. I'm going to pull from an earlier request where I had to read a grid. Okay. Copy. Oh, but first, of course, I need to make my new. Need to make quest 17. Quest 17. New file. main.go. New boilerplate. New boilerplate. Yay, quest 17. 17. Okay, we're just doing part 1 right now. And what was I looking at before? Quest 15? No. It wasn't 13. Obviously it wasn't 16, I just did that. Was it 14? Yeah. 14. Copy that part. Okay, quest 17. So, okay, so I read the grid. Type chord struct x, y of type int atloc chord row equals 0 row plus if strings dot if strings dot contains scanner dot text at strings dot index row at loc chord row at call. Okay, then for row range rows, actually range grid for call idx call range row if row idx row diff row idx minus at loc.x call diff call idx minus at loc.y if row diff times row diff plus call diff times call diff less than 100 less than equal, right? Yes, less than equal 100 if ch is not sum plus equals ch minus 0. Okay. 1606. Yay. The sum of the cells destroyed during this step. Okay. Okay. So. Okay, so now we did that to to. So what we're going to do now is destroyed make map from coord to bool. Coord row idx call idx. Okay, and then we say if destroyed myloc continue max 0 for radius 1 radius one of the edges of the observed area. Should exit radius loop. And we will return max destruction. Max destruction plus equals max of max destruction sum times radius. Okay, and now here radius times radius if call idx len row -1 or call idx equals 0 or row idx equals len rows -1 or row idx equals 0. Okay, yeah, that should be it. No. Oh. Of course, I destroyed my lock. True. I forgot that part. And now, as punishment, I need to wait until this counter goes all the way down. No, again. Okay, let's try this. Where are we? We are at quiz 17, part 2, SAMP. Okay. Okay, well, we disagree there. So, that's interesting. So here what we do is we say p2 debug sum radius sum times radius. Okay, so I went one step further. Okay. Okay, so I don't take the maximum of the product, I take the maximum of that, of the sum. Okay. Okay, max destruction sum, max destruction radius. If sum greater than max destruction sum, max destruction sum equals sum, max destruction radius equals radius. Yes. Okay. So that was just not realizing, not reading carefully. Okay. Stems is fine. Number of each to tangle. Okay. Yes. Starting the loop and closing it as node. Pay the time cost for every cell, for each cell, every time you pass through it. Yes. There's no fastest way to create a loop around the volcano to save as much land as possible. Okay. Okay. Wow. Okay, fastest, so I have to find the lowest radius where it is possible to make a loop. In fewer than 30 times that thing. Okay, so now I mean, it doesn't matter which way I go around the volcano. It'll take me the same amount of time to go around the loop one way as to go around the other. The question is, okay, so I'm going to download this, and then I'm going to move it over. Okay, so we're going to get rid of this, where was this debug statement? We're going to get rid of this debug statement. Okay, now I want to open up Yeah, it does this every so often. I'm wondering if my downloads folder is just way too big, and I probably need to delete a bunch of stuff from my downloads folder. I'm gonna go in this way. Okay. So I just want to check that at is roughly in the middle of the thing. Okay, so I am roughly in the, okay, so the at is roughly in the middle. It might actually be the exact middle, but that's okay. I just wanted to check that it was roughly in the middle, and it appears that it is. Okay, so I've got to pass waypoints A, B, C, and D and get back to the top. And the question is, can I do this in that amount of time? So, do problem 3, at locus that, s loc and then okay, and now what do they want us to return? The number of seconds, radius of 10. Okay, so for radius colon equals 1, radius plus plus, and now I want to say, I want to keep track of the waypoints. Yeah, so a waypoint to the for okay, so I'm thinking here, this is a basic search where coord waypoints int. Okay. Okay. Okay, now yes, I think I'm just going to make a yeah, I'm going to go back and grab from this, I'm going to grab the okay, I'm going to grab the search heap because I want to do that again. Search loc. Okay, and actually for the number of waypoints, I will check that you definitely are in the right quadrant for your waypoint number. Yeah, because it just doesn't make sense to do anything else, really. Does it? It might make sense to curl around. It might make sense to curl around. Okay, I can't check the waypoint number. That's okay. Okay, so what is the lowest? It's just time, right? Yeah. Waypoint where map from where at time 0, that's what I'll put. Yeah. Okay. Okay. Okay, for radius 1, yes, plus. Okay, scene, make map from search loc to bool. Scene of search loc sloc. Zero, zero. Actually, wait. I want to put this there. So, my heap, search heap, heap dot init it won't, heap.init does nothing to a thing of size 1, but yeah. So for len heap heap.pop of my heap dot search look. If current dot time if current dot time is greater than 3, 30 times radius continue. If a turn x div y div y x div times x div plus y div times y div if sqdist current dot where at load less than equal to radius times radius, continue. Then current where else else jump scene bracket search log current.waypoints 0 neighbor chord x y jump.y if okay, and actually, you know what, I'm going to make grid different. I'm going to make grid a map this time. Map chord yes, just chord to byte. If equals slog return current dot time times radius. If current where is equal to slog, yes, return current dot time times radius. And here what I'm going to do is word byte for Actually, we can just do this. We can just say if bang, okay. And now what I'm going to do is I'm going to just shove this on. So, if switch waypoints and if nbr dot x case 1 x outlook.x greater case 2 if then heap dot push search loc from yeah, see, this one is taking me a long time. So the search location will be current neighbor. Okay, we have waypoints and time. There are waypoints. Current dot time plus grid neighbor. Okay. I think that works. Let me go up here, set that, and did I download the thing? I did download the thing. Okay, yeah, of course I downloaded the thing because I wanted to look at it first. Okay, let me take this sample. Input. I'm going to try it on the sample first. Just because. Go run quest 17 p3 samp. Okay, so clearly this is not running fast enough. This search is not okay, 4-line print line. Yes. Radius failed. Okay. So, this is interesting. We are failing way too fast. Okay, so if greater than length of grid okay, so we fail at every radius really fast. Okay, okay, so let me Okay. That's really weird. So I'm going to have to say here, start debugging. Okay. Okay. Now, space. Oh. Okay, let's try that. Okay, I get the wrong answer, but I get an answer. So let's now okay. So radius 10 failed. And radius 10 failed, that's an interesting one because okay, so aha. So if we are actually so I believe that I'm off by 1 because I believe that yeah. Okay. So um 318 seconds. Okay, but it thinks that it can get around it in 298. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. can do it in wait, hold up. Stops. Okay, so it okay, this is what I'm off by 1 on. No. Damn it. Okay, so current dot time. Okay. Time 298. Okay. Okay, let me try this sample. Four time 148. So that I get right. That one I get right. Great. The one that's worked out in detail I get correct. Okay. Let's check this one. Three time 110. Okay, but this one I don't get correct. Because I say that it's possible in radius 9. Okay, so why is this possible? Why does it say that that is possible? 9 times 298. Well, look, I'm going to try it just like that and see what happens. Okay, this is... It got it right on 2 of them. Yeah, I was afraid of that. Okay, so clearly I have some corner case that is wrong here, but I don't know what it is. Cannot figure out what corner case it might be that is wrong. Because it works for the other 2 samples. And the only thing I can think to do at this point is to just print out all of these spots and then highlight everything. And just highlight the whole thing. Okay, so in order to do this, I think what I'm going to have to do is I'm going to have to say previous is pointer to search log. And then this becomes okay. I am worried about this. I'm worried about the scene map. But maybe I don't have to be. Okay. Then text, and then grid roll calls. No, what I want here is I want current. Create function debug print all. Okay. Visited. Make coord. s colon equals look s equals nil, s equals s dot previous, visited append s dot where. Range rows, call ex range calls where chord row call okay. Text modification, no, text formatting. Escape, let's go bracket 1M, 0M. Escape. Actually, if visited of where one M if visited where if grid where val okay colon equals grid where okay okay printf val else so Huh. Now that's really interesting. Rows. And then okay. So what if I do a smaller sample? So I've got my version that is where it's failing. And what if I use the smaller sample where it works and gives me the right answer? Okay, again, it looks like I'm going down, hitting it and going back up. Weird. Okay, so I think I screwed up one of these waypoint things. So what if I remove all of these equal signs so that we definitely have to get into each oh, actually, no. So what I'm going to do, I'm going to say that from S you have to hit 1, 2, and 3. Okay. Here. 3. Case 0 if this is equal, this is greater, and that is equal, and this is equal, and that is greater. Okay. Now we end up going all the way around. Okay, now here. 3180, is that? Yeah. Okay, so I think I got it right now. Okay. Wow. So this will be a 2 hour video. Huh. Man, I congratulate you if you stuck around to the end. That required some weird debugging because I screwed up. I screwed up here in the specs for the waypoints because I just said that you had to hit all four quadrants, and unfortunately for me, the way I'd counted quadrants is it was perfectly possible to go here and then go part way around and then follow exactly back, and you've hit all four quadrants. Just doing one little thing over and back, and then you've hit that quadrant. And that's why I was getting the wrong result here when I ran it. Before when I ran it on the sample, the first time I ran it on this sample, is it didn't. There's the S, so it goes, up and all the way around and then back. The first time I ran it on the sample, it went around to halfway and then back up the same way. You can see that all the way back in, this one. So here, and it might be a little hard to see. Perhaps I should have used something other than bold like they did here. Maybe it's just my font. Anyway, but notice that it went up and then that way to hit this quadrant, and it went all the way around just to here enough, and then it came right back. And so it did hit all of those numbers. It did hit this number just so it would hit this quadrant, but it hit that quadrant easily and came back, and so that's a problem. So what I did is I changed the waypoint calculation to say, okay, you have to hit this side and you have to hit below it, directly below the at, and you have to hit directly to the right of the at. And that caused it then to do the right thing. Whew. Okay, well, do we have, seven? So what I should have done is I should have done 7 instead of 1 when I do my debug print. If I do my debug print here, if I do a 7, then when I run it here, now you can see it much more easily. Okay, well, don't need to know slog. Oh, I also don't need to know that all of these radii failed. Okay, so it does, it is a little slow. It's possible that I could fix it being a little slow by doing some sort of weird binary search, but also, yeah, I mean, I think this is just going to have to be one of those ones that ends up being, you know, more than a second, and that's just the way it is. Yeah, I mean, it's still under 2 seconds, so, okay. Enough of this. I will git add, git commit, quiz 16, and quiz 17. Hey, this is later Daniel breaking in, and I guess I really should be starting the timer again, but we'll just leave the timer at 0 for this. It turns out that the solution I came up with, well, it works for my input. I realized that what I'm doing with the waypoints still isn't perfectly correct. And here is the example I came up with to show that. So I took one of the samples, and this is the last sample that was giving me the trouble. There's the S, it's up there. There's the @ sign. We have 1s all over here, and then we have 9s. And if I run it here with using that sample input, it doesn't make a loop. It goes here, and then it goes back. Okay, that's a problem. So clearly we have an issue with the waypoints, and I think issue with the waypoints in that they aren't all necessarily traveled, you know, so it goes and it starts at S, and then it does tick off something directly to the left of the @ sign, and then it goes under, and it does something directly to the right of the @ sign, but then it goes back under again. So I think all I have to do is that when you go under, if you have indeed already gotten this waypoint, you lose it. So if you have already gotten this waypoint, and you are directly underneath, then you lose it. And I think that will be enough. Let us try again. Yes, because now it makes it back, and yes, time 3 time 117, which is just barely enough, because at 120 it would go to radius 4, and here we check, yes, all the radius 3 things aren't touched. In my debug print, I don't do the radius of destruction. I suppose I could, but I don't. Okay, so that was... Okay, that was... We are changing this. So let's turn the debugging off. I mean, like I said, it still worked for my input. So, you know, we still get the same. We still get the the same correct answer, but just felt I should fix that, having realized that that was a problem. Okay, back to first recording time me. Okay, thank you for watching all of this, if you did, and I will be back with more quests probably later this week. More quest solutions, I should say. Bye. Check out wherever those cards go here. Check out my playlists of everything in the 2025 challenge and everything for Everybody Codes. Bye.